Okay, so let's take a look at implementing this SkyManager class now that we designed in our class diagram. There it is. Somewhere around, where is it? There, SkyManager. I mean, we haven't actually specified any of its members or anything, but yeah, basically what we want is we want to implement a class that is responsible for spawning those background objects, such as the sky, the clouds and the stars and the moon. And it should also be responsible for updating the day-night cycle so that at one point it becomes nighttime and then it turns back to daytime at another point in time. And yeah, those are all the responsibilities of the SkyManager. And yeah, let's get started. So let's go back into Visual Studio here and let's create a new class in the entities namespace. There we go. SkyManager. Let's make it public. And yeah, let's take a second to think about how we're going to implement this. Technically, we could do something very similar to what the obstacle manager does. So basically, what we could do is create a new entity. For example, a cloud entity and a star entity and a moon entity. Or we could just implement them as regular sprites and not encapsulate them in their own class, just use sprites and then have the SkyManager handle those sprites where they are positioned and when they should be rendered and when they should be removed and things like that. We could go either way. I guess it kind of makes sense. Well, I don't want the SkyManager to do too much. So maybe it does make sense to define a new class. But yeah, maybe we can have one class. Let's call it Sky Object or something like that. And this class then describes an object in the sky like a cloud, star, or moon. But it doesn't, we don't have separate classes for each of those object types. We just encapsulate all of the logic in one class and then differentiate between those using an enum or something like that. That would also be a possibility. But now that I'm saying it out loud, maybe it's not that good of an idea. Okay, let's have a quick look at our diagram here. So what I meant is that maybe we could go ahead and create a new class. Call it Sky Object. And this Sky Object would also be an implementation of iGame entity. So there we go. Yeah, doesn't really matter. And the SkyManager would then be responsible for spawning those. Kind of like this. And then we have different types of sky objects like the cloud, star, moon, like I said. And we could use an enum to tell them apart. But then again, I'm not sure because the star, I think, actually has an animation going on as opposed to all of the, well, as opposed to the other two sky object types. Let me actually open up the texture again here. There it is. Oh yeah, and the moon seems to have different sprites depending on the current time of day. And here, it's hard to see, but here we have the star sprites. Those are actually 3 different sprites, so this is actually an animation. So yeah, maybe this approach is not really suitable. I mean, we could do it like that still, but we would basically have one god class that does too much. So maybe we can make the sky object class abstract, like we did with the obstacle, then have different implementations of that abstract class. I think that'd be a good idea. Let's see. Where's the cloud? Does the cloud also have an animation? I don't think so. There it is. Again, it's very hard to see since it's a gray on gray. But let me see if I can get this to there. Yeah, so this is our cloud here, and it's really just one sprite, so there's no animation for that. But yeah, the star does have an animation, and the moon has different states, so their actual behavior is kind of different. So we might even only use an interface to generalize them, because I'm not sure if they actually share that much behavior. I mean, they all should basically move at the same speed, so I guess their update behavior would have similarities. There would be some shared logic, I guess. So yeah, let's go with the abstract class approach, I guess. I guess that makes sense. Yeah, let's just do that. I mean, it seems like a fair and very clean approach. Let me move that down here. Kind of like this. Now let's create 3 classes. First of all, let's make this class here abstract. And then we're going to have 3 implementations, 3 subclasses of that sky object class. Let's call it cloud. And we have a generalization here. And then we have the star. And we have a moon class, excuse me. And all of them are subclasses of the sky object class. There we go. I think this would be a very clean and easily maintainable approach. So, I mean, like I said, we could have the sky, excuse me. We could have the SkyManager just work with sprites directly and just manage all of this stuff on its own. And that would work, but it would be kind of a little bit messy, and I like to keep things tidy and clean. So let's do that. It's fine. This was just to quickly show you what we're going to do here and how we're going to achieve this. So yeah, SkyManager spawns sky objects, and we have 3 different implementations. That looks good. So let's actually do that. Let's go into Visual Studio. And first of all, we need to make the SkyManager an implementation of the iGameEntity interface like this. Let's use IntelliSense to implement the interface. The draw order really doesn't matter because the SkyManager doesn't actually have any rendering logic. So there we go. I think maybe it will have, but for now we don't care about that. Let's see. Let's remove this throw statement. And yeah, now I'm going to go down here and say public class sky, public abstract class sky object. And this is also an implementation of iGameEntity. And then I also want to stub out the implementation of the interface. There we go. Draw order will be an auto property. And the draw method, first of all, let's remove the throw statements. And now I'm going to right click here and say quick actions, move type to SkyObject.cs to move it into its own file. Then I'm going to open that file, and now let's implement this. I guess it will be very, very similar to the obstacle class, so we might even want to I mean, we could consider generalizing those two classes, like having a common base class for both the sky object and the obstacle. Excuse me, but I think we don't need to over design it like that. I think we can keep it simple, and even though some of the implementation may be very similar, I don't think we have to go as far as generalizing those. Again, I think we're good. So let's see. Basically, first of all, let's take a look at the original game to kind of have a point of reference. I really need to check that now, because if it's the same, oh, it's not the same. It's definitely not the same. The stars move slower than the clouds, and so does the moon. Okay, so they don't actually move the same in the same way. It's different for all of them. All right, so I think the only difference really is the speed at which they move when it comes to updating the positioning. So maybe let's go ahead and create an abstract property of type float and call it speed. And it only has a getter. It cannot be set at all. It doesn't change. Just needs a getter for us to retrieve the speed at which the object should move. Let's create a constructor, which can be protected, because a public constructor in an abstract class doesn't really make sense. And we need to pass excuse me, an object of type T-Rex, which would be a reference to our T-Rex instance. And I'm going to add a field here, which will be protected, so that these subclasses can access it. But I will make it read-only, so that it can never change. There. And then we can use that T-Rex instance to calculate the speed for the concrete sky object. So basically for the cloud, it could be like half of the speed of the T-Rex, and then for the star, it could be maybe a third of the speed or something like that. Okay. Now, what else? Well, I guess the draw method, we can make that abstract, because it will be different for each of them. Because for the cloud, we simply need to draw a simple sprite, but for the moon, we need to check, which one of these sprites should be drawn, and for the star, we need to actually draw an animation. So it's going to be different for all of them. We might have even just used an interface instead of an abstract class, but oh well. Now let's say here in the update method, we can actually have that be concrete, but I'm going to make it virtual so that it can be overridden. And let's say, oh, we need a position property of type vector2. And then we can do something like position equals new vector2. Position x minus speed multiplied by game time, elapsed game time, total seconds. Cast that to a float, and the y position doesn't actually change. Okay. And the speed, we don't actually know the actual implementation of the getter here, but that doesn't matter for now. The subclasses will take care of that. And yeah, I think that's it actually. There's no collision logic or anything, it's really just background objects, so yeah. Like I said, we could have just used an interface, I guess. But yeah, that's fine. Maybe No. Maybe we could pass the position here to the constructor as well. Like this, to be able to initialize that as well using the constructor. Yeah, looks good. Now let's start with the cloud because it's the simplest of them all. I'm going to create a new class here, add class cloud. There we go, and it's going to inherit from the Sky object class. Right click here, quick actions, implement abstract class. There we go. And for the speed, what I will do is say T-Rex speed multiplied by 0.5, maybe. And then we need to implement the draw method as well. But first of all, let's create a constructor, a public one. And now let's say we need the sprite sheet, aka a texture 2D. We need what else? We need the T-Rex, and we also need the position. And the T-Rex and the position, we can simply pass that to the base constructor. Actually, we have to. There we go. And the sprite sheet, we can store that in a field. Say private texture 2D sprite sheet. Well, actually, we don't need to. We can just generate a sprite and then store that sprite in a field instead. Excuse me, I don't know what's wrong. There, sprite, and just make sure it's not the sprite class from the SharpDX direct 3D9 namespace, but from our own namespace here. So I can either just use IntelliSense to automatically add the using directive like this, or you can manually type that out here so you have access to that class. Sprite, not spite. There we go. And now let's actually create an instance of sprite. And for that, we need the texture coordinates and width and height of the sprite. See, yeah, I actually already selected it. And that'll be 87 and 0 for the coordinates. Let's define those values in constants. $87, and y would be 0. Whoops. And a private constant integer named sprite width, and that'd be 46, and the height is 17. There. And now we can use those values to create an instance of the sprite class like this. Whoops. There. Pass the sprite sheet and those constant values. Like this. So now we have a sprite that we can render, and that's what we're going to do in the draw method. Say sprite draw, pass the sprite batch, and the position is simply the position property that we inherited from the Sky object class. Okay, and I think that's it. The cloud is really simple. It doesn't do much. Actually, it doesn't really do anything except render itself to the screen. Let's go into the SkyManager class actually here. And now the SkyManager needs to actually spawn those clouds. And let's see. For that, the SkyManager will need an instance of the Entity Manager class. So let's go ahead, create constructor, and the constructor will take an entity manager, an argument of type entity manager, like this. And let me just check here. Oh, yeah. We need to add a field that stores the entity manager, and a quick way to do that is to just right-click here, quick actions, create and initialize field entity manager. There we go. But I don't really like the naming convention here without the underscore, so I'm going to right-click, hit rename, and add an underscore like this. Okie dokie. And now, let's see. Now we can use this entity manager to spawn and despawn instances of the cloud class. Let's see how we can go about that. I guess the draw method doesn't need to do anything. I guess it's kind of similar to what the obstacle manager does. Add a new argument to its constructor of type scoreboard. And I'm also going to create a new field for that. There. Like this. And now let's say, first of all, we'll definitely need an instance of random. There. That we can use to determine the random distance between the individual clouds and the Y position of them at which they're spawned. So let's see. I wonder if the Y position is completely random here. You'd think so. I don't think it's a set of predetermined values, or is it? Or is it? No, I don't think it is. I think basically it picks a random a random value, a random Y position between a predefined range here. I think that's what's happening. Yeah, let's just do it like that. So let's define two constants. Type integer and say cloud min pos y. Whoops. And let's say that's 20. Whoops. And another one, cloud max pos y, which will be, let's say, 70. And then we will generate a value between those two values, and that'll be the random Y position of the cloud. Now we need a field that stores the score as it was when the last cloud has been spawned, or when the last cloud was spawned. Let's call that last cloud spawn score. And we will initialize that with -1. And I guess this time around we could actually just define a random distance in pixels between the clouds. I don't think we actually have to use the scoreboard for that. I mean, for the obstacles, it definitely makes sense. But for the clouds, I guess we can just simply generate a random distance in pixels. We just immediately spawn the first one, then wait until a certain distance has been reached, and then spawn the next one. It's really that simple. We don't need the scoreboard. At least not for the clouds. We're probably going to need it for the day-night cycle, because the day-night cycle is definitely dependent on the score, so it does make sense to have a reference to the scoreboard here. So that's fine, we can keep that, but we don't need it to generate the random distance between the objects. Let's actually simply say private constant integer. Let's say cloud min distance. Yeah, cloud min distance, and let's say they have to be at least 80 pixels apart. And then the maximum distance would be, I don't know, 200 pixels. Okay, so yeah, let's go into the update method and say let's first get all of the clouds that are currently on the screen using the entity manager, and we can use the get entities of type method here. Pass cloud as the type parameter. That'll give us all the clouds, and there might not be any yet. So let's say if clouds count is less than or equal to 0, or clouds max position y let me just complete this here first, and then we'll talk about this for a second. Clouds max okay. Yeah, let's go ahead, create a new field. Private integer target cloud distance. That is where we're going to store the random distance between clouds that we have generated. And here we're going to say TrexRunner game class the width minus let me put that in parentheses. Okay, so what I'm doing here is, first of all, I'm using link. I'm using extension methods from the link namespace, which are count and max. And count will give me the number of elements in the enumerable. And here, if the count, if there aren't any clouds, so if the count returns a value less than or equal to 0, or the window width minus the greatest of the largest y position of all of the clouds is greater than or equal to the generated value here, which we should probably rename. Oh, no, I just used the wrong field. Whoops. Excuse me. There. So I'm getting, with the max method, I get the largest
X
position out of all of the clouds that are currently on the screen. And I subtract that value from the window width, which will give me the distance from the right side of the screen. Of the distance between the right hand side of the screen and the cloud. And if that is larger than or equal to the target distance that we randomly generated, then I want to spawn a new cloud. Or if there isn't any cloud yet on the screen, which would be true if the count method returns 0. So yeah, let's go ahead here and first of all generate this value. So random next, and the minimum is the cloud min distance. The maximum is the cloud max distance plus 1 because it's not inclusive. That is okay. And now we need to randomly generate the y position. Like this. And now we can actually spawn a new cloud. Say cloud, new cloud. As the sprite sheet, which we don't have yet. So let's add another parameter to the constructor of type texture2d. Call it sprite sheet. There we go. Store it in a field. Like this. Oh, there. And now I can pass it here to the constructor of the cloud class, like this. And I can pass the T-Rex as well, which I don't have. So again, here, let's just right-click, quick actions, create and initialize field. Now we have a field here, and I'm going to rename it T-Rex with an underscore. Okay. I guess we could also make the sprite sheet read-only because it's never going to change, but it doesn't really matter. So let's pass the T-Rex here. And the position will be a new vector2 where the X position is the window width. And the Y position will be the value that we just generated. There. And then we can add that to the screen using the entity manager, like this. And we also need to make sure that clouds despawn. Oh, there. And we also need to make sure that the clouds are despawned as soon as they leave the screen. So let's say for each cloud, let's just call it C. In clouds, and I guess technically we could say where. Let's call it CL. And then here we're going to refer to it as C. See where position X is less than, and let's go with 200. Minus 200. So if for each cloud that has a X position that is less than negative 200, we will execute the following logic, which will simply be entity manager, remove entity, and pass the CL variable here, which is an instance of cloud. There we go. And where is also an extension method from the link namespace, and it simply returns all of the elements in a collection that satisfy a specified predicate or condition, which in this case would be the X component of the position being lower than minus 200. And there we go. And yeah, I think we're actually already able to test this. Let's go into the TrexRunner game class and add a new field. Of type SkyManager, call it SkyManager, create an instance of that somewhere, it doesn't really matter where here, somewhere in the load content method, maybe here. Pass the T-Rex, pass the sprite sheet texture, pass the entity manager, and the scoreboard. And then we need to also add it to the entity manager so that it gets updated. Okay. But I guess the SkyManager yeah, I think if we need to go into the sky object class here, and we need to check here in the update method. We need to check if the T-Rex is actually alive, and only then update the position, because when we're in the game over screen, the objects in the sky should actually stop moving. So only change the position if the T-Rex is alive. Okay. Guess we're ready to test it. Let's see. Oof. Those are a million clouds at once. So let's take a look what went wrong here. So we use the window width minus the maximum. Oh, minus the maximum X position, of course. Whoops. Let's try that again. Maybe that already fixes it. It looks much better. But I guess we should play with those distance values a little bit, because they're much too close together. So let's go up here, min distance, 80 is not enough, let's say 120, and the maximum is, let's say, 400. Start again. There. Still pretty close together. But I'm actually quite satisfied with how fast they move. And actually it kind of looks okay. Maybe 120 is still a little too low. Let's go with 150, but I think 400 is fine. yeah, I think we're good. Looks great. So perfect. It looks just like in the original game. So great. Yeah, so that's taken care of. So let's see. Yeah, what type of sky object we can implement now? It can either be the star or the moon.